Okay, this is a response for Ben Yohama's questions about speciation and whether we should be concerned that sterile members of a generation might in fact be the next species within our genus, and whether we should be testing for this sort of thing and things like that. And I think Nicotine 2 actually has done I assume that's how you pronounce his name, has done a good job explaining that speciation is a slow process. It's not something that happens instantly, but because this is a very, very common misunderstanding of species, and the reason I think it's misunderstood is because the word species and the way it's defined is really terrible. And the reason I say this is because species is kind of this idea and this word that has survived since before we had understandings of genetics and heredity and so on. So that while the idea that two animals can't interbreed and have viable, fertile offspring is sort of this useful heuristic. I would use the word heuristic. It's a quick and dirty test that most of the time it gives you the right answer, but it's not guaranteed. And a prime example of this, and I only know this because I was talking to somebody else about this exact same issue of, well, how do you really define species, is alpacas and llamas. Talking to someone who breeds llamas, they were like, well, it's kind of strange because you can interbreed alpacas and llamas and they will have viable, fertile offspring that can continue many generations without any particular signs of problems. And this is interesting because these aren't only not the same species, they aren't even the same genus. For a long time they were thought to be the same genus, but through genetic testing they were shown to actually be in the same family, not the same genus, based on the branching of common ancestry throughout the family or order, whatever. So what I want to point out here, though, is that this shows that while the idea of interbreeding is kind of, it's a useful way to look at things, it's really not a strong way to look at it, and it reinforces this idea that there's a hard line where species stops and starts, and there really isn't. So anyway, that I think is a very important thing to point out, that the word species and its definition, the way it's usually defined, is something that creates this confusion. So I wanted to point that out. He talks about how, Nicotine 2 talks about how there's this slow progression, and that's important to consider. I mean, that's sort of the basic answer. But also I wanted to talk quickly about speciation, how that occurs, and common misunderstandings of that kind of relate to the misdefinition of species, and also relate to some really basic ideas that people have about common ancestry and evolution and things like that. So, and I think this is sort of important, and I think it's something a lot of people, even people who've studied a lot of biology, kind of miss sometimes, and just it's easy to think otherwise. So I think it's ridiculous whenever creationists talk about, oh well, we came from monkeys. That's ridiculous, right? They say things like that, and it's silly because we didn't come from monkeys any more than monkeys came from us. Our closest relatives are not our ancestors. Rather, as the language goes, we share a common ancestor. And the way that speciation happens is you have a population of individuals of a species, and generally the population becomes separated into two groups, where the two groups are separated usually by some kind of geographic barrier, whether it's a group migrates off to one other area that the other group isn't in, or common examples have been the formation of land bridges or continental drift, things like that. So you have this geographic separation of a population of a single species. Once those populations are separated because they're no longer interbreeding, the two different populations accumulate different sets of mutations, which leads to speciation, which is where one species continues on its journey of adaptation, while the other group also continues on its journey of adaptation, but is adapting to a different set of environmental factors. and that's what causes speciation. So as long as you have an interbreeding group, there will never be speciation, because what speciation is basically, the idea is not that you're changing from one species into another, it's that one species is diverging into two groups that can no longer interbreed, eventually can no longer interbreed. And so that's an important thing to keep in mind, is species don't become just based on, well, one day you're one species, another day you're another species. And the reason is because the idea of species is really a terrible one. There's no point where you've accumulated so many mutations you're suddenly another species. There's just a point where two different populations start accumulating different sets of mutations. And so as long as the human race is generally interbreeding, we're not going to see a group of the human race become a subspecies or some separate species that can no longer interbreed. And anyway, so I think that considering sort of how speciation works and the fact that the word species and the way it's defined is kind of misleading, I think that sort of covers a lot of the misunderstanding here. I think it's very common. So anyway, hopefully got some new information about that, or out of that. And anyway, I think it's interesting because the mechanism of speciation is so poorly understood by people that they think that humans are more evolved than bacteria, where really bacteria have been evolving just as long as us, and not only that, they've had many more generations in their evolutionary time because they have such a much shorter reproductive time scale. So whenever somebody's like, well, why don't we look at these, really primitive organisms, how is that going to just come about randomly? Those aren't primitive organisms. Those organisms are just as evolved, if not more evolved than us, depending on whether you're looking at time or generations in terms of time steps. And that's why you see these incredibly complex bacteria. They're not simple organisms. They're incredibly complex. And they've been evolving just as long as we have. So anyway, common ancestry, interesting idea. Speciation is a split in population where different groups accumulate different sets of mutations. Hope that clears things up. Thanks.